So what happens when you get a bunch of super smart, specialized AIs together in one room? You'd think you'd get this perfect symphony of intelligence, right? But a lot of the time, what you actually get is just chaos. Turns out, building a real AI super team is one of the biggest hurdles in the whole field. But today, we're going to look at a new breakthrough that might have finally cracked the code.
And this, right here, this is the million-dollar question. I mean, we've got these AI models that are total rock stars at what they do. They can write, they can code, they can analyze data like nobody's business. But how do you get the coder, the critic, and the planner to actually work together smoothly? How do you make them a real team instead of just a bunch of brilliant individuals kind of tripping all over each other? The researchers behind this paper have this really fantastic analogy. They think of each specialized AI as an agent, or, get this, a puppet. And each puppet has its own unique talent. One's a master researcher, another's a brilliant coder, maybe a third is a super sharp-eyed critic. They are the individual players all ready for a master to guide their strings.
Yeah, but as anyone who's ever managed a team knows, a group of experts with zero coordination, that's just a recipe for disaster. And the early attempts at making AI teams work, well, they ran straight into this wall, and it showed a huge fundamental problem with how they were designed. See, those early tries used what we call static systems. To put it simply, imagine giving a group of actors a totally rigid script. They have to say their lines in this exact fixed order, no matter what's actually happening on stage. And you can guess what happened. It led to all sorts of issues. Wasted effort, really clunky coordination, and at the end of the day, it just didn't perform very well.
So, okay, the rigid pre-written script was a total bust. What the team really needed wasn't a better script, it was a brilliant director. And that is the big idea at the heart of this research.
So meet the Puppeteer. This whole new way of thinking brings in a central orchestrator that, you guessed it, pulls the strings. It watches the project as it's happening and decides right there in real time which specialized AI agent needs to jump in for the very next step. It's smart, it's adaptive, and honestly, it completely changes the game.
This is the crucial shift. We are moving away from a fixed, pre-planned process to something that's dynamic and intelligent. The AI team now has a conductor who can improvise, who can adapt the entire performance based on what's actually needed in that moment.
But how does this director know who to call on and when? It's not just guessing. The Puppeteer is actually learning and getting better and better over time. So let's take a look at how that actually works.
It's really a two-step dance. First, you have the dynamic orchestration. That's the Puppeteer picking the best agent for the job right now. But here's where the magic really happens. Adaptive evolution. The system uses a process that's basically learning from trial and error. After every task, it looks back and asks itself, okay, did that work? Could we have done it faster or cheaper? It then uses that feedback to fine-tune its strategy, becoming a smarter director with every single project it finishes.
Now, the theory is really elegant, but here's the big question. Does it actually work in the real world? Does this AI director actually lead to better results? Well, the data tells a pretty clear story.
Just look at this. What you're seeing here is a huge leap in performance. On this really tough reasoning benchmark called MMLU Pro, even a monster model like Llama 3.1 scores a 0.76. But the Puppeteer system, after it's had time to learn and evolve, it hits 0.83. This is proof of a really powerful idea. A well-coordinated team of specialists can actually outperform a single giant genius model.
And check this out. It's not just about being better. It's also about being smarter with resources. The system gets rewarded for being both successful and efficient. So over time, the evolved Puppeteer learns how to solve problems using way less computational power, or tokens. It just gets the job done with less waste.
All right, now this is where things get truly mind-blowing. When you let the Puppeteer learn for a while, it doesn't just get better at its old plan. It starts to develop entirely new, much more sophisticated strategies, all on its own.
And this is such an important distinction. You know, it's the difference between a student who gets really good at memorizing facts for a test and a student who actually learns how to think and reason from the ground up. The Puppeteer system is learning how to think more effectively about teamwork itself.
So the first strategy that pops up is something called compaction. At first, the Puppeteer might try using a bunch of different agents, but over time, it actually discovers a small elite squad, a core group of hub agents that just work incredibly well together. It then starts routing more and more work through this super effective little subteam, making the whole process way more dense and focused.
And then there's the second strategy, cyclicality, and this is just incredible. The system learns to create its own feedback loops. So one agent might create something, then pass it to a critic agent for review, who then sends it back to the original agent to make it better. This is literally the AI equivalent of a human team brainstorming, critiquing, and iterating on an idea until it's perfect.
So, what does this all add up to? I mean, these emergent strategies, they're not just clever little tricks. They are pointing towards a radically new future for how we build and how we collaborate with AI.
The authors of the paper really nail it with this quote. This isn't just about making a bunch of agents talk to each other. It's about discovering the most fundamental, essential patterns of how to reason together and then using that knowledge to build incredibly powerful and scalable AI systems. And all of this leaves us with one just fascinating question. We're moving from just programming AI to creating systems that can learn how to build their own expert teams. So, what happens when these self-organizing AI super teams are finally turned loose on some of our biggest challenges? The possibilities are, well, they're truly extraordinary to think about.